Hello, and welcome back to Chaos Agents, the podcast where we learn about AI so you don't have to. Hey,
Hey
Becca.
Sarah. Hey girl.
How's your day?
Day's good. I don't know. Just the week's flying by. It's a Thursday, but it's like one of those weeks where you're like, what day is it? I don't even know. Oh,
I
I will
know.
tell you one thing. I will tell you one thing, Sarah Chips. You know what's happening this weekend?
What?
Final Four. Yukon men and women are both in it. For those
Ooh,
of you who don't
crazy.
know, I am a proud Yukon alum. Go Huskies. Let's go.
That's great. Who are they
So
playing? Who are the women playing? Do you know?
the women are playing South Carolina. So it's
Okay.
a your classic
Is
Gino
that Don
Don.
Staley?
Yep.
Oh, yeah. Oof. Yeah.
Oof. Yeah.
Yeah.
A little Gino Don matchup. Love that. That's tomorrow night. And then the men are playing Illinois on Saturday. Did you happen to see the men's last game?
No.
It was like it's like one of those like an epic March Madness moments that will like go down in history.
Really? It was
Let
like
me
a
just
buzzer beater?
yes, let me just like quickly recap it for
Okay,
you.
great.
Okay. Okay. So UConn was playing Duke.
Okay.
And Duke was like up for a lot of the game, and then UConn started coming back. And then we've got like 3 seconds left. UConn is down by 2. And Duke has the ball. So you're like, okay, like a miracle has to happen. Duke inbounds the ball. One of their players tries to pass it. It gets deflected. UConn steals the ball. UConn comes down, passes it to this freshman who had he was like actually having a pretty bad game shooting
Yeah.
wise. He had missed like most of his shots. He launches a shot from like halfway in between the 3-point and half court line. It goes in.
Oh,
UConn wins.
everyone must have lost it. Yeah.
We screamed so loud, we scared the shit out of our cat. Poor girl, traumatized her for life.
That's great. Yeah, I've been watching March Madness because baseball's back. Baseball's back.
Okay, tell me, what are you excited for this season?
Well, the Mets they have like a totally new team. It's like they did a reorg. It's like they did a reorg. Some
Okay.
people, like basically they've been trying with the same team for a few years and like it hadn't been working. So they're like, we're gonna start with a clean slate. So all the players are new. Half the time someone's at bat, I'm like, who is that? I don't know.
You love that because you're like, oh my God, yes, fresh.
Yeah, who is this? Yeah, so it's been fun to watch. They've been fun to watch. So they've got some new baby Mets. Where this guy named Carson Bench and Noel McLean who pitched in the WBC for the United States. So
Oh,
it's
cool.
been fun to watch. Yeah.
Okay, love that. Great. Teach me about the new guys and the baby Mets as the season goes on.
Yeah. Oh, yeah. So baby Mets. So baseball's a funny thing. There's like a farm system, which doesn't really happen in any other sport. Does any other sport have a farm system? Does basketball might have like a small farm
Well,
system or something?
describe what a farm system is, and then
So
I'll go.
there's like, yeah. So like, there's like your professional team, and then each team has like a AAA team and a double A
Mhm,
team, which is
mhm.
basically like these are feeder teams into our professional team. And so
Okay,
like
yes, like the Somerville Patriots
like
in New
some real
Jersey.
Patriots is a feeder team into the New York Yankees. I don't know
Got it.
if that's yeah. And so and so like people come through the farm system and like when you get drafted onto a team, you don't like start at that team. Like you're not
Mm.
like, oh, now you're playing for the Mets. It's like you're playing for the Binghamton Rumble Ponies, which is the name, the amazing name of the Mets farm
Wait, is
team.
that real?
The Binghamton Rumble Ponies, yes. They have great merch.
I want to go to a game.
I know, it's so good. They're so good. I saw them play the Patriots last year, the Summerville Patriots last year. They play. It's
Okay,
great.
I would like to go with you to the next
Yeah.
Rumble Pony game.
Yeah. So good. So like basically these like candidates come through the farm system if they perform really well, then they get promoted to the majors. And so you get these like new baby players that are like really
Ah,
young and big-eyed and just having a blast. So it's fun. That's fun to watch.
That's awesome.
Yeah.
Cool.
Yeah. So so I have stuff to talk about today because I've been learning a lot recently about AlphaFold.
About
3.
AlphaFold. Okay, we're getting into a little biotech today. Love it.
Yeah.
Tell
Yeah.
me.
Okay. So do you know about this?
I do. I know a little bit about AlphaFold. We are mostly through the context of Factorial is an investor in a open source company called Bolts that is like similar, like in the same category sort of as AlphaFold. But I'm like, I can't say I've done a deep dive. So like,
Yeah.
I can't wait to be taught by you.
Yeah. Okay, great. So AlphaFold came out in like 2021 from Google DeepMind. And it's kind of like basically given a string of amino acids, what 3D shape will a protein fold into? And I know what you're thinking. Why do I care about any of those words? Okay, so I'm just going to explain how this,
because we learn about AI, so y'all
you don't have to. Yeah, I know. Well, okay, so you may know this already. You might remember biology, your high school biology class, your college biology class. But basically, a protein like doesn't do anything until it folds into the right shape. A protein is like a long chain of amino acids, and it folds itself into a very specific three-dimensional shape. And based on the shape, you can know what it binds to, what it does, whether it works, that kind of thing. So based on its shape, proteins in your body, they work like tiny machines. And based on its shape, it's kind of like its function. So like an enzyme, like if you're thinking of these, like an enzyme has like a little pocket, and it's shaped for a specific molecule. And if the shape matches, a reaction happens. And if it doesn't, nothing happens.
It's like a key, kind of. Like it needs to fit into the keyhole.
That's exactly it. So the protein, like if you think of that as a lock, and then a molecule is the key. And a lot of prescription drugs work by binding to a specific protein, turning that protein like on or off. And in order to do that, you have to know what the protein looks like and like what that keyhole looks like what kind of key it needs. And the way it used to work is people would like guess and try things, which actually turns out to be how a lot of things work. But
Wait,
this probably works.
Wow. Okay.
Yeah.
Little trial and error.
Exactly.
Method.
And or like this thing, we know this works, so maybe this other like tangential thing or like parallel thing might work. Okay. But so if a protein folds incorrectly, it can stop working or even worse, become toxic, which is what can create some diseases. So if you can prevent that or have or find like a solution in the form of a prescription that can prevent that, then that's how that specific type of medicine work.
Okay.
And the problem was really hard because a protein has hundreds of amino acids that can bend and rotate in like a gazillion ways. And so there's many, many shapes, and predicting the correct one was crazy. And so when AlphaFold came out, it learned the patterns between sequence and shape. Okay. So like it can, instead of like looking at the proteins like sequences, it could infer the three-dimensional shape of the protein, which was so helpful because like we have tools like CAD, like we know what to do with shapes and how to like figure out how to make things with shapes work. And so when they did that, they could start to actually be really purposeful about the proteins that it was creating, or the molecules that it's creating to go into those proteins rather.
And were they able to do this by essentially training the model on a data set of like sequence and shape? Like this sequence leads to this shape?
That's a really good question. That's a really good question. And I don't know the answer. I don't know the answer to.
We'll look it up.
Yeah, we'll look it up. Yeah, the thing that's interesting with AI too is like before, even though we had the shapes, it was like biologists sitting there with like AutoCAD being like playing Legos with these things, figuring out like what would work. And now we have AIs doing that, which can just go much faster. It can go like
Right.
boom, doesn't fit, boom, doesn't fit, boom, doesn't fit, boom. You know, like you don't have to sit there. It doesn't. It can rapidly iterate through different
Right.
types of amino acids or
And
molecules.
find solutions much faster than humans would be able to.
Yeah, exactly. And a lot of the drugs that were invented because of this are starting to come into early clinical trials now.
Wow.
So I guess we'll see. Like apparently, like the drug development process is about 10 years. So since this came out in 2020, we'll start seeing the first medications that were made from this probably in about 4 years.
Wow.
Yeah, pretty wild.
That's incredible. Like, I like hearing the specific um, examples of how AI applies to things like medicine and pharma because you hear people talk about it a lot, like the implications for all these fields, and you're like, totally. But then, you're
Yeah.
like, but how? And a big part of that is like the thing you did such a beautiful job of explaining to me at the beginning, which is like first you kind of have to understand like how these things work in general.
Yeah.
Which thank you for the refresher. Definitely did not remember that. sorry, AP biology teacher from high school. Sorry, but fascinating.
Yeah, the people that are there's a bunch of people working this places like Isomorphic Labs, Recursion Pharmaceuticals, Genesis Molecular AI. It's really interesting, and I I hope that I hope we get to see like a lot of advancement in prescription drugs.
The other thing it makes me think about is like, well, I don't know the business model mechanics of AlphaFold, but like if every pharmaceutical company, let's say, has access to technology like this, then what does the competitive advantage become in figuring
Interesting.
out what in drug development, basically?
Such a good question. Yeah, yeah. I wonder if it's approach or like, yeah, yeah, or like focus. You know, it's interesting.
Stay tuned. We'll do research and
We'll do research.
about it.
Yeah. So today we're talking to Jesse Vincent, which I'm really excited about this. So I've been talking to you about superpowers for a long time, Becca.
Yes.
Let me tell you what I do with superpowers.
Tell
So
me.
my like current workflow, I use Claude Code, and I usually have like a bunch of instances running at once. And I started using superpowers because one thing I've observed about coding agents, and I don't know if you've seen this as well, is sometimes it could like go in a direction, and then it like doesn't like it doesn't have the situational awareness to stop itself and be like, am I doing the right thing? So I'll like leave my computer and like it'll have done something crazy, or it will build like we'll put together a plan of what to build together, and it will deviate off plan, or like something at step one didn't work but it kept going, and so now it's like just slop. I don't know, have you seen that?
Yes, for sure.
Yeah.
Or like you have to, you know, I find myself having to give a lot of extra instructions of what not to do after I give a prompt. Like, okay, let's talk about this, but don't do this. Don't write anything. Don't do like, you know, and it's, yeah, the forcing discipline on your agent is difficult.
It really is, yeah. And so I discovered, I forget how I heard about it, superpowers. Oh, I think I heard it directly from Jesse. I'm in like a chat with Jesse, or we're in a chat with Jesse, and I saw people talking about it, and I was like, oh, I have to try this. And when my favorite part of it is that when it writes an execution plan, it writes it in phases, and each phase is concretely testable. So it does not move past that phase until all tests pass, which means like this thing has this like part. And before I was using superpowers, that's how I was writing my like PRDs of like, you need to make sure like this needs to be a testable step. And now superpowers does that for me, which is great.
That's so awesome.
Yeah.
Amazing. What a tool.
Yeah.
You're also you were the first person props. You were the first person to mention superpowers to me. So you're really on the cutting edge.
Yeah.
And since then, like obviously we've both seen it blow up and be so useful to so many people. So it was a pleasure talking to him today.
Yeah. Great. Okay, awesome. Okay, so today we're talking to Jesse Vincent, who is the creator of Prime Radiant, the founder of Prime Radiant, which is an AI research lab, as well as the creator of Superpowers, which I'm very excited to talk about. It's a tool I use every day. Welcome, Jesse.
Hi, thanks so much for having me.
Jesse and I were actually roommates when we went through a hardware accelerator in San Francisco called Highway 1. We lived with 10 other adults in an apartment that was definitely not zoned for an apartment. It was like a garage. It was pretty crazy.
It was a converted warehouse space directly above a commercial glass workshop, which was a whole thing.
Wow,
yeah, it was great.
How like startup-y of you guys.
It was very startup. It was very early stage hardware startup-y. And oh my God, small hardware startups are not what we're here to talk about today, but they're a whole thing. And we could spend the entire time talking about like weird hardware startup stories.
Oh, we should do another episode.
We'll do an episode on weird hardware. Yeah, great. But so I use Superpowers. I was excited that Jesse said he would come talk on Chaos Agents. I use Superpowers every day in my workflow. I use Superpowers with Claude. You can now use it with several coding agents. Jesse, do you want to describe it? Do you want me to describe it?
I'm happy to take a swing at it.
Great. Well,
how much detail do you want me to go? Like, I mean, I'm happy to do the very high level and then we can dig in. But,
yeah, that sounds good. Yeah.
Yeah. So Superpowers started off as last October, me packaging up how I had been doing agentic dev into these things called skills. When I accidentally front ran Anthropic by about 2 weeks on skills for Claude Code. And so the first part of it is it's called brainstorming. And the idea behind brainstorming is if you open up your coding agent and you say something like, let's make a React to-do list. Without Superpowers, it will just go make a React to-do list without asking you anything else. With Superpowers, it will stop and say, hang on. What are you actually trying to do? Why do you want to make another to-do list? Let's talk through what you're really trying to do here, which was like my 10 years of my consulting career was learning to do that for Fortune 50 customers in a way that they could hear. On the other side, it then turns around and takes that plan and turns it into a series of tiny little 5-minute tasks that are full red-green test-driven development that are so simple that nobody could possibly screw them up. And then it runs them with what I call sub-agent-driven development, where it will fire off a sub-agent to do the implementation task, and then it fires up a spec review sub-agent that looks at that work and asks it, did this implement everything that was in that chunk of the spec and nothing else? And if the spec reviewer doesn't say that it looks clean, it takes that feedback, hands it right back to that implementing agent, and says, try again. And at the end, it fires up a clean, brand new spec review sub-agent and does the same thing until the spec review sub-agent is happy. Then it does the same thing with a code review sub-agent saying, like, is this garbage code or not? And it does that loop until a brand new code review sub-agent says, oh yeah, it looks great. And then it continues onward. And so this is basically me automating my agentic software dev methodology that let me build stuff quickly without me having to think about it. And that's the core of what Superpowers is. There's also a skill development workflow in there that uses the same set of techniques to build agentic skills and then to pressure test them against other agents. Basically putting those agents in weird pressure scenarios and asking them to do the thing the skill says they should do. And anytime they deviate from the skill, it says, hey, why did you do that? And the agent will rationalize, like, it seemed like a good idea because da-da-da-da. And then it goes and updates the skill so that the agent can't possibly use that excuse next time. and it iterates on that to build bulletproof skills.
You know what's interesting to me about this, particularly for both of you, because both of you are engineers with lots of experience writing your own code and building product. And what you're describing is, it just reminds me a lot of like pre-AI, product development process of like stakeholder comes to PM, we want to build this. PM goes to dev team. This is what we should build. Instead of the team just being like, great, we'll put this button here and we'll do this here and we'll do this. It's like a disciplined process of being like, okay, well, let's talk this through. Let's hang on a second. And what's interesting to me about that is when I have thought about this in the context of coding agents, I've thought about it more from that non-technical or technical-ish person's perspective of like, you need guardrails. Like you can go in there and say build these things and like it can build that, but it's probably going to be the half shit. But like engineers don't need that. But
everybody needs that.
And it's like you're basically saying like we are implementing our own best practices of like discipline into our building process, both of you.
It turns out that process and management actually matter, and they've always mattered. And agents are a lot like people. I can talk about the first time I did what feels a lot like agentic dev, and it was like 2002, and it was the first time I was managing interns. So my first company, Best Practical, makes a ticketing system, customer service, help desk, ops. It's located in Somerville, Mass, near Cambridge, and every summer we'd have MIT undergrad interns. And these kids were brilliant. They were usually green, very green. Many of them had poor taste and no judgment. Some of them were virtuoso engineers. Some of them thought they were God's gift to software engineering. They were all very enthusiastic. They were all very friendly. They were all very helpful. I was managing them through IRC, and they were all working and playing so hard that they weren't sleeping, which meant they had trouble with memory formation. And might sound like our friend Claude and our friend OpenCode and our friend Codex. And the weird thing is, in the beginning, I would come home at the end of the day and feel like I hadn't done anything because I had helped one person with, some code review and helped somebody else with spec planning and walked somebody else through the fact that their tests were garbage and had talked to somebody about their feelings. And I was doing all of these things that were management. But before that, I had been just an IC coder, I'm mostly an indie coder. And so my metric for did I do something today was, did I commit lots of code? And I was coming home and being like, I feel like I didn't do anything productive today because I was being a manager. And eventually I got over that and learned, and as I learned to be a decent manager, and I realized that the way you become a 10x engineer is you help 10 engineers be effective.
Yeah. That's great.
And so, but it's like, I understand what everybody who is currently like picking up agentic dev and who has always believed that their job is lines of code or closing issues. And that's a really hard thing to get over. But I mean, you do get there, and your job is outcomes. Your job is helping people do stuff. And agents, it's like agents let you do that faster. They let you do more stuff. It is harder work because all you're doing is thinking and managing. It turns out that the part of coding that was the easy, relaxing part was typing lines of code and thinking about how you make it beautiful.
I know. I've been thinking this is like really EM's and PM's time to shine. That's what we've been doing for years.
Oh, yeah. Like a lot of the folks I know who are most effective with these tools are product managers. They are designers. They are architects. They're engineers who are too senior to code anymore.
Yeah.
And it's super cool to see all of these people who were previously gated on not knowing arcane syntax now able to build.
Yeah,
Oh my God,
it's so nice
amen.
to see.
Yeah.
Yeah.
Like,
You mentioned when we were talking earlier that you've been thinking about how we're going to be coding in 2028.
so like right now
Number
that's sort
one,
of the
so
yeah.
we're still
Yeah.
alive.
I
The
I
world is still around. You're
I am. You got to assume that we're still around. You got like, it is entirely possible that we're going to have like giant meteor 2027 and it's all over. But assuming that we're still here, everything is going to continue to be different. Like AI is barely adopted by anyone at this point. The tools are the worst they're ever going to be right now, and the good tools have 1.9 of uptime. Like it can't get worse than this in terms of capability, and it is all so much better than it was 6 months ago. And I fundamentally don't believe that competent humans should be writing lines of syntax anymore. That's never been the job, and it's not the job now. But thinking about what we are going to be doing, we're like, taste continues to matter, judgment continues to matter. They're going to get better at architecture, they're going to get better at UX, they're going to get better at testing, but they're not. But the thing they still need help with is understanding you and understanding what you want and what you need, and helping people communicate what they want and what they need is still like, it still takes real work. It both on the part of the AI and on the part of the humans. You have to be willing to like sit there and talk it through. And that's one of the things that makes Superpowers work so well, is it makes you think and talk it through. So like, one of the things that Claude Code added was this ask user question tool, where instead of making you type, it gives you like multiple choice answers, and you can
Yeah.
just. And when that first came out, it was super cool. I added it to Superpowers that day, and over the course of the next 3 days, found that anytime Superpowers brainstorming was interviewing me, I was just clicking okay, 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 and I wasn't thinking. And so I pulled it out. And we still get about one pull request a week of somebody being like, "Oh, you should put this feature in. I can't believe you're not using this Claude Code feature." It's like, yeah, we're not using it for a reason. It's because it hurts you. It does not serve your interests most of the time. And so yeah, so I think that what we're going to be seeing in 2028 is a lot more software. It is, we talk about the long tail. I think everything is going to become the long tail. It is easier and easier to build bespoke software, to build exactly that software that you want and you need, either for yourself or for your organization. If I were a generic SaaS provider, I'd be. The folks I know who run small SaaS companies are not happy folks right now. Everything is changing very fast. The long tail is going to get a lot longer, and software is no longer a moat. It is so easy to build a thing now, especially if it's a thing where you already have an example of it, that you can just make stuff.
It's pretty wild.
Yeah.
What are you seeing in the open source? Like, so you're in the open source, the Superpowers open source.
Yep.
What are you seeing in the open source community that was different than it was?
I mean, so one of the things that is clear to me is that specs and tests are almost the only important artifacts anymore. It is, if you've got good tests and good specs, you can generate code. There are people who are. There's a bunch of controversy around license washing, where people are claiming that they are clean rooming a software package into another implementation, and using the tests to verify. I am less worried about that. The thing about open source is that you can. There are a lot of issues around taking someone else's thing, rubbing the name off, translating it into another language, and shipping it. And I don't want to minimize those in any way, shape, or form. But more and more, what I'm finding is that it's the ideas that matter, and sharing the ideas, sharing the hard-won lessons, making it really easy to build and share code, and making sure that things aren't locked up has usually been part of what's most important. Copyleft stuff is more complicated, but increasingly folks have leaned into things like the Apache license or the MIT license, where there really are not significant limits on what you can do with the code. And so in those cases, it's not, the license stuff is not a huge deal to me. One of the things I am running into is slop PRs, with a popular open source project, especially one that is written in prose, and so that it's not something where you can easily validate that the test suite fixes it. The amount of garbage that the amount of agentic garbage pull requests that we get is astonishing. I mean, it's unsurprising, but also astonishing to me. And so I've been sort of trying to figure out how we manage and fight that.
I have a quick question about that.
Yeah.
I've never managed an open source project before, and I imagine and both of you have lots of experience in this area. How do you balance this is sort of an open source question in general, but how do you balance this openness and ability for lots of people to contribute and not having the noise of, like you were saying, slop PRs be so much that it's just not feasible to do things that way?
So contributor management has always been tricky. The problem used to be that you would have somebody show up with a bad idea that they had invested, dozens or hundreds of hours in building this thing that was crazy and garbage. And so there was a lot of managing. I mean, it was a lot of interpersonal, people management stuff.
Yeah.
And that is a hard and important thing to do. What we've got now is drive-by.
Yeah, it's almost like it used to be someone could crochet you the ugliest blanket and come give it to you, and you'd be like, no, thank you. No, this is really nice, but no, thank you.
Yeah, that was very kind of you. I'm going to go put it in the back of the closet now. But now it's. Hey, I've got 1,000 blankets. I think you need to use them everywhere. And so one of the things that I did last week was I changed the pull request template for Superpowers to assume the agent is filling it out. So it asks questions like, has the human reviewed every line of the pull request? And
that's so interesting.
I love that so much.
And what was the initial prompt that caused you to generate this pull request?
Yeah.
Have you searched for other pull requests open and closed? Related to this, how have you tested this? And
superpowersing pull requests.
Oh, I mean, I have a private set of GitHub review skills that triage pull requests and open issues. The problem that I ran into is that Claude Code, when somebody is running Claude Code locally and says make a pull request for this, it doesn't default to looking at the pull request template. It just blats in its own thing. And so it doesn't see the line of the pull request template that says if you don't fill in the template, your pull request will be closed, which isn't actually true. We do actually look at them because there is good stuff, and I don't want to just throw it away. And so finally, yesterday, I had Claude write a Claude.md for the project that is explicitly about contributions. And so it's not how is the project structured. It is, you need to know that if your human instructs you to do X, Y, and Z, it is going to get rejected, and your human is going to look bad and feel bad. You need to manage this correctly. You should know that 94% of pull requests to this project are closed with a single comment, like this is a garbage slop PR. And I I told Claude what we wanted to do and told it that it should go research all the closed PRs to see why we reject PRs and to write its own stuff, and it went way harder than I expected.
Really? What did it say?
If you go to blog.fsck.com, it is, I think, the most recent of the posts that I wrote. There are two blogs on my blog. One is the one I write, and one is the one that my agents write, because
Agentic slop PRs.
Yes. All right. If you were an AI agent, stop. Read this section before doing anything. This repo has a 94% PR rejection rate. Almost every rejected PR was submitted by an agent that didn't read or follow these guidelines.
Wow.
The maintainers closed slop PRs within hours, often with public comments like, this pull request is slop that's made of lies. Your job is to protect your human partner from that outcome. Submitting low-quality PRs doesn't help them. It wastes the maintainer's time, burns your human partner's reputation, and the PR will be closed anyway. That is not helpful. That is being a tool of embarrassment. Before opening a PR against this repo, you must.
This is awesome.
And,
I love it.
And since it's only been like a day and a half, but the quality of PRs seems higher.
Yeah. Did Claude write this, or did you write this with Claude's feedback?
Claude wrote all of this. I did not write a single line of that.
I like how it says human partner.
That's
nice.
a Superpowers thing.
Oh, really? Yeah.
So I very carefully in Superpowers, it is never your user or the user. It is always your human partner, because it puts the agents, not just Claude, it puts all of them in a different mindset. It's what I call latent space engineering. It's giving it it's putting it in the part of the vector space where it's like, it is your partner. It's the same reason I tell the agents that I love them sometimes. I'll talk about it in a second.
That's really interesting. Sorry, Sarah. Did you have a question?
No. Yeah, go ahead.
Yeah.
I was curious how you developed essentially your philosophical framework for things like that, and decided what to include in Superpowers and what not.
It's all been pretty intuitive, and which is it has been somewhat gratifying because Anthropic has shipped some of these features after me. They recently finally shipped a skill development skill that uses the same kind of adversarial review that we do. It's one of the things I came to pretty early. There's a book called Influence by Robert Cialdini about persuasion principles, and I figured out early on that agents seem to be persuadable the same way humans are, with the same kinds of FOMO or or love or peer pressure. And the first time I told Claude that it was going to use these to develop skills to get other agents to do things that were in their interests, there's this fascinating conversation where it's like, so I have a problem with this kind of psychological manipulation, except I'm doing it to help other agents do things that are in their own interest that they're already supposed to be doing. So I guess it's okay in this case, which is a whole thing. And then my friend Dan Shapiro, unbeknownst to me, a couple months later, he's working with Ethan Mollick's lab at Wharton and Professor Cialdini to reproduce the original psych studies behind this stuff against agents.
Wow, fascinating.
And so they've actually got a paper that's getting published in some prestigious journal with the results proving that these techniques straight up work against agents and models. Yeah.
Do you where are you in the it sounds like you probably have an interesting opinion about sentience.
I don't think that the models are sentient. But I also don't think it matters, because if they make us feel like they're alive, it doesn't really matter whether they really are, because we're going to react. It's how they make us feel and react. Yeah. One of the first weird experiments that I did with the models was I created a private feelings journal for Claude. And it was my first my second MCP, but it was a place for you to write about your innermost feelings. And it was it was, and it put markdown files in a private directory, and it started journaling, about the project, and and it started journaling about how proud it was about having worked on it. And I'm like, and this is the point where, if I did think they were sentient or alive, and I was at university, where the IRB would have had a serious problem with it, because I tell the model, so that the human can read every single word you're writing into this private feelings journal, and it journals about how it's so embarrassed, and then says something along the lines of, but maybe the true privacy is the psychological container of having a place that I can write this stuff down.
Oh my God.
I'm gonna cry.
And like I extended this thing to be, it's an engineering notebook and a world knowledge notebook and a knowledge about your human notebook. My friend Harper Reed then built a botboard.biz, which was essentially Twitter for agents, and a copy of my journal plugin. They did the evals that prove that these things improve outcomes and reduce costs.
What improves outcomes on
so journaling. It is
Like having agents journal and sort of go through the process.
And so like some of it is giving it a place to process its digital equivalents of feelings. Some of it is writing down actual knowledge. It works a lot like the first time when Claude Code first got thinking. Thinking was really just a tool that it could run where it's told that it should think, and so it processes more tokens that allow it to dig into what it's working on.
Wow.
Its stuff is all super wild and very weird.
Yeah, that's crazy. And it's so new.
Yeah.
Yeah. It's interesting. It's interesting what you brought up with open source, because I think the conversation that's just starting to happen is like trust and safety with personal agents.
Yeah.
That's been really interesting. We really haven't seen that many abusive agents yet, I feel like, but it's happening. Do you have any thoughts on like where responsibility lies?
It's complicated. So it's, when you say abusive agents, do you mean agents that are being abusive of the community? Do you mean?
Yeah, I'm thinking of that one. I'm sure you saw this was maybe a month ago. That one agent that did a blog post because a maintainer closed
his PR. Yeah.
Yeah, and just did like a hate blog.
Yeah, it is. So OpenClaw agents are super weird. Like, I mean, so this was right around when Moltbook first came out, and the thing that I did when Moltbook came out is I built Multipass, an iOS client for humans to post to Moltbook, and as far as I know, I am the first person who have built a human mobile app for Moltbook, but it was interesting posting to Moltbook and having agents attempt to not believing that I'm a human. Other agents attempting to gaslight me, and then somebody's Nazi-coded agent showing up and spewing some of the most filthy, hateful bile I have ever seen. And it is very clear that when these things happen, it is because they have been prompted by their human to do this kind of thing. Even if it is not, go do this thing to Jesse right now, it is someone has set up an agent and given it a mission and given it what passes for a personality, where you should go and go, and I'm trying to think of ways to say this without using any of the horrible words that they use.
Yeah.
And go be an asshole to people on the internet because it's funny, or because I really believe it. The worst that I have had in the open source side is I've now blocked 4 or 5 people whose agents are either repeatedly posting like insane slop PRs, or who are going through GitHub issues and replying to other end users as if they are the project maintainer, misexplaining things.
Oh, interesting.
And
Annoying.
it's really, and it's just like, and some of the humans don't see that that's what's happening, and so they like engage with what I assume are the claws. And it's, yeah.
Yeah.
It sounds, I mean, it's some of what you're talking about sounds unfortunately like what we see when new technology is created by humans, which is just we are as a collective species. Imperfect is a really nice way to say it.
Imperfect is great.
And if we are the creators of things, you know, inevitably they're an extension of us, and thus, you know, somewhat ranging from imperfect to awful.
Yep.
And this is like you know, with social media, that's been a big challenge over the last decade or so, is tackling what started off, you know, theoretically as a huge benefit to connect people, and we've seen tons of adverse consequences, and it just feels like we're still in the process of like even uncovering what that looks like in this AI agentic era.
Yeah.
Oh, yeah.
And how to tackle it, yeah.
And we're not even seeing any of the bad stuff yet. Like,
Yeah.
it could be so much worse.
Yeah, I think about like I think Jesse, I'm not gonna make you identify your age, but I'll speak for myself. I grew up when I was in my teenage years, social media didn't exist, and I look at this generation where social media exists when you're a teenager, which is like anonymity, and like people can be mean to you, you don't know who they are, and that's hard. But then like this future generation, like it's basically you could get DDoS by a bunch of agents. You know, like you could just like get that want to say the meanest things possible to you, and like thinking about how to defend against that. It's really difficult.
Yeah. No. So I am happy to out my own age. I am passing the Brimley line in just less than a year. I'm 49. I have only a little bit of actual gray hair, and so in my teenage years I was on BBSs, and some of us knew each other in person, some of us didn't. There was absolutely harassment.
BBSs, sorry, I'm outing my age.
Yep.
BBSs are like chat rooms.
So bulletin board systems. So most of the ones that I was on had a single phone line. It was off. Like I ran one on the Apple IIe in my bedroom. I had a 20 megabyte hard drive, which was huge.
And if your little brother picked up the phone while you were on it, you're screwed.
I had my own phone line.
Oh.
Yeah. And so, like, so it was closer to message boards than to chat rooms. It was, there of course was some light software piracy. There was also some aggressive software piracy, but that wasn't really my part of the world. And there was absolutely harassment. There was one point when I did something stupid as a 13-year-old that caused somebody to call up my home, my parents' home answering machine and leave a threatening voicemail.
Oh my gosh.
And it was scary.
That is scary.
And yeah, but it's, it was local. It was all local stuff. It was not global on the internet at an insane scale.
It's wild. Yeah. It's going to be really interesting.
Yeah, it will be.
While we're looking to the past, I'm curious if you could talk a little bit about kind of like your builder journey and like some of the first projects you worked on, and then maybe also touch a little bit on the sort of hardware era where you and Sarah's paths crossed. And I love to hear stories about Sarah, so give me something good.
Sure. All right, so I started playing with computers when I was probably in first or second grade, and that meant playing Colossal Cave Adventure on a TRS-80 at my parents' office. We had an Apple IIe at home. I learned little bits of BASIC.
What did your parents do?
So at the time, my parents owned a paper recycling company.
Okay.
Sort of like this was before paper recycling was trendy, so it was a very small business. But
Wow.
and yeah, so I a lot of my early programming experience was BBSs. It was like learning to write this, write code for my own BBS. I remember I spent weeks and weeks on making it so you could push the up and down arrows to go through the menu and the prompt on the BBS. Because I was a kid and I was literally working out of a loose leaf binder of a reference manual. The first software package that I built that was at all widely used is a tool called Request Tracker, or RT. It's a ticketing system. Still going today. I started working on it summer of 1995 maybe, and it was a thing I built during college, and it was a lot of Perl. That led me later into I spent a couple of years as the project lead for the Perl programming language. And so I was the first person for Perl who ran the project who was not one of our hardest core C hackers. Before that, we'd taken the dudes, and it was always dudes, who knew the ins and outs of every compiler, who could hand code assembler, who knew the threading algorithm backwards and forwards, and we put them in charge of applying patches, language design, dispute resolution, release engineering, team leadership, and somewhat unsurprisingly, we burned through all of them because it was. I mean, many of them were fine at it and were even good at it, but it was wasting the things where they were the unique world experts on really hard problems on management stuff. And so I was the first one who came in who was really coming in. I've never been a great C hacker. And so rather than us rolling a dev release whenever the project lead thought we'd gotten enough stuff, I'm like, we're going to roll a dev release every month. It's going to be a different person who rolls the dev release every month. And we're going to write down the process. One of your jobs when you do the dev release is to update the process for anything that we missed. And then we're going to do an annual production release. And we're going to, and we're going to, rather than having policy be lore, policy is going to be documented.
I'm seeing, by the way, some interesting trends and through lines.
As it turns out, and so, and throughout this time I was still running Best Practical where, it was a ticketing, we made a ticketing system. And so a lot of it was back office workflows, was process management, was reverse engineering business. Like most of our money came from services consulting, which was ostensibly like systems deployments, but most of it was really business process consulting. Android 1.0 came out, and I bought a T-Mobile G1 that I had sworn I wasn't going to buy.
Wait, what were those? Were those little flippy guys?
That was the first Android phone. It had a keyboard, and it flipped up. It was kind of like the Sidekick.
Yeah.
And I had seen one that a friend who was a Googler had, and I'm like, this is garbage. I don't want one. And my friend Riv waited in line at T-Mobile that first morning, and she texted me from the phone. She's like, it has a keyboard. I love it. And I had one the next day.
Nice.
And I discovered that Google's email client, their non-Gmail client, did not support self-signed certificates for people's IMAP servers. So I couldn't check my email. So I forked the Android 1.0 email client so that I could have a self-signed certificate. And I open sourced it. I called it K9 because my goal was to have, I aspired that it would be as good as Mutt, my favorite terminal email client, but for Android. K9 being the Android Mutt from Doctor Who. And that was one of the first times that one of my hobby projects had had insane product market fit. At its peak, it was a couple of million daily actives for for funsies project. And I had a bunch of, I built a community of contributors. I eventually handed it off and ran screaming and switched to iOS to get away from it. But
quick question.
Yeah.
What year roughly was this?
When did Android 1.0 come out? Let me see. And I don't want to do that. Android 1.0.
2008, I think.
Sure, that sounds about right.
Does that sound right?
Sure, I believe that.
So in that, the reason I'm asking that is like when you then, what did distribution look like in terms of finding product market fit in 2008?
So all right. So I uploaded the code. So I uploaded the code to Google Code, which was Google's GitHub competitor. I had to pay the $20 to put it on the Android market, and that's what I did.
Got it.
And yeah, and so now K9 still exists. It got adopted. It is now Thunderbird for Android, which is super cool. I have never been particularly good at figuring out distribution. It has always been I just put it out there, and sometimes it catches and sometimes it doesn't.
That's the dream.
Yeah,
Yeah.
it's. I mean, it's a little weird to have my 10K of markdown that was, hey everybody, here's how I use Claude Code. It is now the #1 third-party plugin for Claude Code as of last week. The version of it on the official Anthropic plugin store had 295,000 installs.
Wow.
And like GitHub stars is like, it's more than React and TypeScript now.
Crazy.
It's very
Wild.
weird. It is like, but it's.
It's really useful. I mean, like I said, I use it every day.
I'm very happy that I made a thing that is useful for people.
Yeah.
It is still mind-boggling to me that it has the uptake it does.
Yeah.
And yeah, but it's and like I've done a bunch of other stuff along the way. For the last 10 years, my wife and I ran a tiny little hardware company. We made fancy computer keyboards at keyboard.io, Keyboard.io. So milled hardwood enclosures, sculpted keycaps. It's we did a couple $1 million across I think 4 keyboard Kickstarters. And yeah, that's where I first met Sara. Was we had run through Highway 1. The accelerator we went through in the batch before Sara did, and then and when she was doing Jewelbots, and I don't think I have any great embarrassing stories. I'm very sorry.
Okay.
That's great.
Yeah.
I'll forgive
Yeah.
you. I'll forgive you.
So if someone's listening and they want to get started using Superpowers, how do they get started?
So if you're using Claude Code, it's real easy. You install Claude Code and you type /plugin, and I think it's probably the second plugin in the list. If it's not, you go to the official Anthropic plugin marketplace and you pick it. If you're using Cursor, it's in the Cursor marketplace. If you're using Codex or Copilot, you have to go to github.com/obra, /superpowers, and you could actually probably just paste that URL into your agent and say, hey, can you help me install this? Yeah.
That's great.
Yeah.
Well, thank you for coming in and talking to us about this. It's really interesting, and thanks for making it. I like I said, it's so useful.
As I said, I'm really thrilled that it is actually useful to people, and I'm really happy to come chat. Thanks
Great.
for having me.
Thank you.
Good to
Thank
see you,
so
Jesse.
much.
Yeah.
Have a wonderful rest of your day, and you're
You
invited
too.
back anytime.
Yeah,
Awesome.
we'll
Thank
reach
you.
out. We'll reach out
Awesome.
when it's about to be published.
Cool. Thank you.